So a question for you then. Where are you in your process? Do you have customers today? Is your business up and running, or it's a very early stage?
So we have the benefit of actually touching the ground running, since it's based on university research for 7 years. So we have since December a product. We have our first implementations for the purpose of doing predictive maintenance. Thank you. So we actually have deployments. Okay. So we're at that stage, and we're doing an extensive rollout right now.
And I know that you actually got some funding.
Yes. So we announced a funding round last week where we have Almi Invest and Jane Walerud as investors in the company.
Now you're looking for people, right?
Always.
Yeah.
Always looking for competence. Always.
Not people, competence.
Competence. Great.
It comes with people, right? Hopefully.
At least for the moment.
Yes.
Still. Okay. So,
We've done very much. How much data do you need? How clean does it need to be? Because most of the data that has been collected is not as clean as you actually want it to be.
Sorry, how much data do we need?
How much data do you need, and how clean is it?
Well, that's the thing. We use all different. This was actually a smaller example. So we use actually very large data, tens of millions of observations and so forth. And the actual dimensionality in terms of features is largely irrelevant. And the second part of your question is how clean does it have to be? That's actually one of the very important benefits of our methods. It doesn't have to be very clean at all. It's very good at picking out the signal from the noise, which is, of course, a large problem when you have such huge amounts of data with just a small amount of signal. Of course, you can never get more out than the data actually provides.
Okay.
I just like to follow up on your question here. Those people who are used to sort of more standard statistical techniques and so on, they may want to know some rule of thumb. When does it pay off to try to use these newer techniques with your topology or machine learning? What roughly one used to say you must have much larger data sets to work with compared to maybe traditional statistics or other rules of thumb that help us to see where the potential can be.
Right, well, we find that we do have the greatest benefit with larger data, but we have applied it to smaller data sets and still come out with slightly better accuracy and better partitioning of the data that's important. We generally do a classical analysis in combination with our own topological data analysis to verify sort of the baseline that we can expect and whether or not we're exceeding that expectation. So, I mean, we can work with all different sizes of data.
Another related aspect is sort of price of false positives. If you make sort of these well-known examples of Netflix, you get recommendation of other films that you may like. The false positive doesn't cost anything.
Right.
But in life science medicine, you must have bounds on your errors and things like that.
Okay, yeah, so there are two parts to the answer. The first is that we use internal cross-validation, and we actually run permutations or a bootstrap, making maybe 1,000 different combinations of data partitions into training and validation to make sure that it's an unbiased estimate. So usually the results are quite robust. And the second thing is that usually this is, in life sciences, this is to be considered more of a hypothesis generating tool. So anything you find with this, you would have to replicate in an independent cohort, just like with any life science experiment, to be absolutely certain before you would create a diagnostic test or a treatment schematic or something.
I can just add a related experience. Commonly used a quote from Mark Twain, who said that statistics is to most people what a lamppost is to a drunken. Something to lean against rather than get enlightened by. And what we've seen is that computers are very good at doing certain things. And as people, we typically have a hypothesis when we look for something, and then we find that in the data. A machine is unbiased, unemotional, and can actually find very interesting correlations. We did a housing automation case where we learned in the process that an apartment 2 floors down had a bigger impact on the temperature in one of the apartments than any of the surrounding apartments. Couldn't be explained why, couldn't look at the building and figure it out. However, something in the construction actually transferred the heating. So sometimes it's actually interesting as a complement, not always a replacement, but machine learning and the pure mathematics and very unbiased, unemotional approach to it can be very useful as a complement. At the back.
Gunilla Torstensson, Tillväxtverket. I have a question regarding data scientists. There is a shortage of data scientists. Is that a problem for you in your processes now? That you don't find the people you need, or will becoming a problem perhaps?
So I actually have a controversial view on this. Oh, sorry. So my view is actually that data scientists will become, so this is kind of the opposite of what people think, but I think it will become a less relevant profession as time goes on. Because a lot of the things you hire data scientists for now, I think that people who don't have that background could do. So for example, if you have, and the way to bridge that gap is with great software. So in the old days, you'd have to have a lot of data, and you have one guy who's very, very good at analyzing that data, and that's why he's a data scientist. But let's say that you had, way more sophisticated software that could allow you to just ask the questions you want to ask and get the answers from the software. Then actually a lot of the stuff that a data scientist does would be automated away. Of course, the counter argument to this is, sure, but there's also more need, there's also more demand for that kind of work. But I think that when you balance these two forces, the net result is going to be that there will be less data scientists and more good software.
And I can just add to that, because we see that as part of an opportunity for us. And as I said in my presentation, we've developed our product for developers, for programmers. In many cases, they quickly grasp this. They use mathematics on a daily basis. It's a question of kind of understanding the context and so forth. And we talk a lot about the democratization of machine learning and this kind of intelligence, because that's when it becomes really valuable. If you're a data scientist and your profession is to do data science, and you compare to someone who has a very, very long, extensive domain expertise, then typically that is where you can really identify and solve the problems. So you need both. And I think that, for example, today, people with a programming background has a big advantage because you understand the logics of the computer, and thereby you understand the possibilities and the limitations. I think that in general, someone who has an understanding for what data science means and how structured data and all these different things, how it relates and what you can do based on it and how it correlates, has an advantage. But I really believe in the fact that this becomes valuable when everyone gets access to it. We have to make the tools better and easier. We have one over here.
Are there any patents in your business, in your company?
Not in our company specifically, no. And the thing is, I normally say that we work more in the commodity space. We built a solution that solves, typically, we try and really make this available, that solve the small problems. Instead of trying to boil the ocean and doing everything that's in the forefront of deep learning and everything else, solve the problems at hand, like the gasket case. Like I say, the basket case, the gasket case. Solve the problem at hand, make small steps, and then you can make larger steps. And for that, there are very good commodity technologies available. We made an application for how we use it rather than focus on algorithms or patents in our case.
I think we had a question back there first.
Yeah, I don't want to ruin your day, guys, but all the three of you guys assume that all the incoming data is correct. To my experience, the legacy data is normally 30% is correct, but 70% is crap. How do you segment the data that comes in, legacy data? Maybe not you, because you are using new data.
So I just go, we have a very easy answer to that actually. So so the data that comes in, we let people, basically to use a term from a hedge fund manager called Ray Dalio, we believability weight people based on who they are. So for example, anyone who's a technician who just started 2 weeks ago, if they record a case that we call cases, which is, the actual input and then what the diagnosis turned out to be, that person's final case goes into a queue, and then other people has to approve it. So we actually are very, very careful about what data we allow to be part of the model.
So how do you, sorry to interrupt you. How do you make sure, how do you validate the data? Especially you, Ryan, because if you let that data come into a deep dive algorithm system, you bring in a risk, and then you fuck up everything in the end.
Right, so our data analysis platform inherently partitions out the data that it thinks is most important for the decision making, and then it does cross-validation, so it builds a model on half the data and tests on the other half, but it does this 1,000 times with different partitions, so that the result is usually quite robust. And then as a final check, you should always test it on some new data that's independent, depending on if it's a industrial process or a life science experiment and so forth. So usually the results are very robust and unbiased.
But you agree with it? If you don't validate the incoming data, you could create chaos about it. Especially you with your, what you're doing, you analyze cancer and so on, as you described. You need to be damn sure that the data is correct.
Well, like I mentioned, if the data is not correct, usually the incorrect data is thrown away from the modeling process initially. So when we have, actually Wojtek can maybe comment further.
I can comment. So, right, we cannot upfront determine if this data is correct or it's not correct. Okay? We can analyze, and often when data is compromised, we just don't get an answer. We just sort of see like, okay, sometimes they compromise data when there's a strong signal. But again, we can just sort of say whatever, that's information in this particular data, and then it has to be validated. Independent. If someone sort of sends us, we actually had cases in which data was apparently was supposed to be true real data, but it was synthesized. And we saw a very strong signal. It was just a guy, he knew how it should look like, so he just synthesized, and we detected the signal, like to synthesize. And then, at some point we got the real data, and we couldn't see anything except that. So yeah, we cannot say that, oh, this is true, this is not true. We can do something about the data, and then we have to validate it. But this is, it's not. That's a trouble. It's a reality.
Understood.
But we cannot sort of verify it's true or not true.
So I can also say, since we're talking about automation today, typically our recommendation when it comes to automation is start small. That don't try and boil the ocean. Start small. And we've had a number of situations where we actually ran the data and we looked at the outcomes like, Jesus, it's 100%. And if it looks too good to be true, it's normally too good to be true. Then you typically have some kind of variable that is actually directly correlated that screws up the entire algorithm. So for us, it's typically in automation a good approach to take its small steps at a time and try and really figure out what kind of problem do we want to solve and solve that, and then add and then solve that. An iterative process. Think in terms of the roadmap, just like we do in software development, instead of trying to solve every problem. It's different when you have life science projects. I'm just saying from an experience when it comes to automation that could be a way of thinking.
Did you have a question?
How did you solve the gasket problem? With a sensor or?
Yes.
What kind of sensor?
Pressure.
What?
So we're using pressure sensor as the core sensor. Then we're using external sensors like heat or temperature and humidity. And we're also adding, actually, obviously it changes the color of, thank you. It changes the color of the elements, and thereby you can actually add that to the equation. So we're doing that as a follow-on.
That was pretty expensive sensors.
Well, yeah, so that's actually a very good reflection, because in my opinion, sometimes you need very precise sensors because you need the precise value. Sometimes you need something that shows the difference over time. So it doesn't have to be that precise. It doesn't matter if it's 21.22 degrees or if it actually shows 22. What you want to figure out is if there's a change over time. So it always relates to the starting value. And sometimes the sensors are expensive, sometimes they're less expensive. Depends on the implementation and what you're going to use it for.
Yeah, there is not quite a good standard for sensor. I've been in sensors for 44 years. Sure. And it seems in the beginning it was just on-off, a switch, yes. But that doesn't give you a signal. You like to be able to see when to make the service. Yes. And the analog signal, what kind of signal is used for you? You have a box and then you collect the data on the machine in a processor somewhere.
Yes.
What is the standard? Because I see it's very difficult. Every company like to make their own buses. They create E2C, but that is only for PC boards. And then it came IO-Link, which is a club for multinational companies. Right. And I like, it's a target for me, to fight multinational companies and Asia. I had my father, he made an invention where he just made a lock ring. The first one was placed on the moon in minus 273 degrees, 3000. Patent, it was just money and lawyers. I helped him to get the financier, and today when he's dead and this, 3,000 million lock rings are produced. Right. For example, one could use that principle, elastic strain prelude, that's his name. Instead of the gasket, you put a metal gasket which has prelude, then you don't have to control them in the 50 years.
So this is one reason why we stay away from the hardware side of the business. Yeah. We provide a software solution that's being embedded, and then we work with systems integrators to develop the whole solution. Yeah. This is certainly pioneering work. I mean, it's pioneering in every aspect, on sensors, on platforms, on software, on standards, on backbones, on backends, everything. And there are many things that has to mature and evolve. But that's an area we don't touch.
Yeah. The last question is, as a conclusion, what would you suggest that we take for a system to transfer, let's say 10 meters sometimes, or what bus system? 4 to 20 milliamps?
I'm not the right person to ask that question. Like I said, that's where we use system integrators. Yeah. So I'm sorry, I'm not going to be able to answer.
We have to look.
Yes.
Still,
I can point you to people that can answer the question, but I'm not the right person. Sorry.
That's something which is really breaking up the whole what you are working with, because they like to create own standards.
Right. Absolutely.
I think for those kind of questions, we also have a fantastic crowd around lunchtime here in the house, actually. That can be very, very, very deep focused on buses and different methods.
I write you and ask, and you transfer it to somebody who gives me the answer.
Yes, please.
Because I collect answers for a couple of months or years,
okay,
and
great.
then we go for that.
Cool.
Or we make it cheaper. Other solutions go around.
I think we have time for 2 more questions now. The first one is here.
So that means that your system could also be used to pinpoint things that really have to be redesigned. Like you were saying, changing the extrude gasket to another material, for example, if that is a problem.
Yeah.
Could be. Like I said, attribution is a tool that I find extremely valuable and useful, for example, for production optimization, to really find what is the thing that has the biggest impact. Like I said in the housing automation case, figuring out what other apartment has the biggest impact on the indoor climate in my apartment. It's really cool, and I can certainly pinpoint and identify that this is the one thing. Like in your golf swing, what's the one thing you should change to make it better? that's that kind of approaches, and then you can look for other solutions that could actually resolve that better. True.
Okay, one more question before hitting the coffee again. Are we satisfied?
All good.
We're all good? Thank you so much.
Thank you.
Thank you.
Thank you.